Good morning, students. This is Mr. G. We will be looking at today chapter 2 of Amplify, and we are going to look at where do sediments in magma come from. Your warm-up today, I will do this warm-up with you. I would like you to first answer, where do you think magma comes from? There's no right or wrong answer. I just want you to tell me where you think it comes from. Now, where do you think sediment comes from? And finally, where do you think magma and sediment, or how do you think magma and sediment form? There are no right or wrong answers with that warm up. I just wanted to see where your head is at. So, we have been looking at the Rocky Mountains and the Great Plains. The Rocky Mountains and the Great Plains have very similar mineral compositions. Remember, minerals are what make up rocks. These rocks, even though they look very differently, are very similar. The Rocky Mountains are tall and gray and pointy. These are made out of igneous rocks. Igneous rocks, remember, are formed from cooled magma. The Great Plains are formed from sedimentary rocks. Sedimentary rocks are formed when sediments compact and cement to each other. Our question today, looking at this, we know that these rocks are made from igneous rocks, and igneous rocks are made from cooled magma. We see that sedimentary rocks are formed from sediments, but where do magma come from? And where do sediments come from? Where do these two things come from? We don't know yet. My first question for you today is, where do sediments in magma come from? My question that we are first going to examine is, what causes sediments to form? Please write this question down. Matter, remember, is anything that has mass and take up space. My pencil has mass and it takes up space, so it's made out of matter. My phone has matter and it has mass and takes up space, or my speaker has mass and it takes up space. My body has mass or it takes up space. These are all things with matter. Energy is the ability to make things move or change. Energy is what causes matter to change. So if you see anything that is taking up space and it changes over time, that means energy is enacting on that object, making a change. My hair is an example. My hair is going to look different in these videos. That is because energy is acting on my hair and changing it over time. As a reminder, a map view is what the top of something looks like, and a cross-section view is what the inside of something looks like. This is a cross-section of the Earth, and with the sun, not to model or scale, way outside of it. Energy on Earth can come from two things. It can come from the sun. The sun can be giving energy to Earth. And the core of the Earth, the super hot core of the Earth, can be giving energy to the Earth. I'm now going to open my simulation to see where is energy in our simulation and how do sediments form. So I'll go ahead and open my simulation. I'm going to click here. Instead of going on process mode, I'm going to go to energy mode. And I'm going to turn on energy from the sun. So weathering, I just want you to observe what happens. I now want you to write down your observations of what just happened below. Thank you. What I observed is energy from the sun was causing clouds to form and move, which rained down on the rocks, breaking these rocks into little pebbles that moved downstream. And after millions of years, they cemented and compacted into sedimentary rock. Let's watch a video on this phenomenon. Ah, great. So, weathering is the process of rock breaking down into smaller pieces due to wind or moving water. Please write down the definition of weathering now. Erosion is the movement of sediment from one place to another, often caused by wind or flowing water. Please write the definition of erosion down now. The key concept is that sediment forms when any type of rock is weathered, a process driven by energy from the sun. So now we're going to learn, where does magma come from? My second question is, what causes magma to form? Write down the question now. Matter, remember, is anything that has mass or takes up space. Energy is what causes matter to change. In our cross-section view of the Earth, we can see that energy comes from two locations, the sun and the core of the Earth. We're going to go back to the simulation and we're going to learn about, and we're going to make more observations. So in my rock transformation simulation, I can turn on energy from Earth's interior. You can see that when I turn on energy over 1,000,000 years, the mantle is going to melt into magma. The magma is going to shoot down into either the surface of the Earth or below the surface of the Earth and create and melt down at the top. This creates a new rock called igneous rock. When the magma cools, it creates igneous rock. Okay, I want you to write down what were your observations below while watching the simulation. What did you observe happen? And how do you think magma is formed? Let's go back to the simulation, or back to the video. Let's watch a video on melting candy. If we're good, I will do this experiment in our class. So in this video, you can see we are putting hard candy, which is supposed to represent our rocks. Jolly Ranchers represent our rocks. We're going to turn up the heat. And slowly, these rocks will begin to melt and melt and melt and melt. As it melts, it will cool down, and when it cools down, it will form into a new shape. Let's take another type of candy. This candy looks more like sedimentary rock. As the sedimentary rock melts and melts and melts and melts and melts, it will begin to look different. And as it cools down, it will cool into a different shape. So, the key concept here is that magma forms when any type of rock is melted, a process driven by energy from Earth's interior. The energy from the interior of the Earth, from the core of the Earth, melts down the mantle into magma. The magma will go to the Earth's surface and cool down, creating a new type of rock. So now I want to go to our digital sorting tool, and I want us to see this cross section of the Earth, and I want us to figure out where does weathering occur and where does melting occur. I want you to tell me, point on your own screen, where would weathering occur and where does melting occur? Very good. Weathering happens at the surface, and weathering is caused by the sun. Melting happens in the mantle, and it's caused by the Earth's interior. So now we're going to try to explain how energy changes rocks. My last question is, how do rocks change because of energy? Energy, remember, is the ability to make things move or change. Energy is what causes matter to change. Matter is anything that has mass and takes up space. And for rocks, a lot of their matter is made out of minerals, pure inorganic substances that all rocks are made out of. So, sedimentary rocks are formed when sediments are compacted and cemented to one another. Igneous rocks are formed from cooled magma. Sedimentary rocks can melt down to become super hot magma. And when the magma cools down, it will be an igneous rock. Igneous rocks, through weathering and erosion, will break down into sediments. And sediments that are compacted and cemented to each other become sedimentary rock. I want you to write down first, how do sedimentary rocks become igneous rocks? Now I want you to write down, how do igneous rocks become sedimentary rocks? The key concept here, matter gets transformed by energy, but the same matter is still present. So even though the minerals are completely the same, they have turned into different and new rocks. I want you to write down your key concept now. Let's do some practice exam questions. Will be on your final exam, so I want you to take these exam questions really seriously and try to get them right. Giovanni and his family go on a road trip and they drive over a mountain range. Giovanni wonders how the rock they see as they drive over the mountain range might be different. And when they drive back home next week. What would you tell Giovanni about how rocks will change? Georgina is a rock collector. She's looking at some information about two of the rocks she collected on her travels. The information is as follows. Rock A formed from small pieces of rock. Rock B formed from liquid rock in a different place. Rock A and B formed about the same time. Are the rocks the same or different? A geology student describes a rock sample she is studying in class. The rock sample is igneous rock, but the student wonders if the material that is formed was part of sedimentary rock millions of years ago. Could this be correct? Could the material for igneous rock come from sedimentary rock? On the island of Hawaii, Keanu notices that the sand on the beach is black, the same color as the rock formations on the island. Keanu realizes that the sand used to be a part of rock formations. How did the material from the rock formations turn into sand? Reina is making museum exhibits about two different rock types. How could energy have played a role in the different rock types forming? Finally, geologists have evidence of an igneous rock formation under Earth's outer layer. Is it possible that material from this rock formation could ever form sedimentary rock on Earth's surface? Thank you. Have a good day. Great job on Chapter 2.